Thank you. So yeah, I've been coming to PyCon UK since 2014, and yeah, it's great to be back. This is my conference badge and lanyard from the last time. So I haven't given a talk in real life since that conference 3 years ago. So yeah, really cool to be back and glad to catch up with everybody. Get to make the same joke I make every year. Take a photo of the picture outside. Say that was PyCon UK in 1916. So to make that joke on Twitter every year. I just wanted to point this out. There's a nice little video that Nick Tolliver made a few years ago at PyCon on the education track, where he interviewed Russell, who we lost last year. It's a really funny video, so if you've got sort of fond memories of Russell, or you didn't know about him, just watch that video. I tweeted a link of it earlier, and you can catch it on the slides as well. So yeah, do recommend that. It's a good, really funny video. So yeah, my name's Ben. I'm a software engineer at BBC News Labs. You may remember me from previous years. I used to work at the Raspberry Pi Foundation, so I gave a lot of talks here about that. I'm now a PyPy critical project maintainer somehow, but that's a story for another day. I'm based in Cambridgeshire, and I'm on Twitter, and you can see my links there as well. So I'm now working at BBC News Labs. So we are a multidisciplinary innovation team within BBC News and BBC R&D. We kind of make prototypes of new audience experiences, and we make solutions to help journalists. We also do lots of research, and we just try out lots of ideas and see what works. We've got a website there with we write up all our projects, and we're also on Twitter as well. So a lot of the stuff I'm going to be talking about, just to give it a bit of context, these are the kind of projects we've worked on in the last few months. So we worked on a project recently called IDX. So this was about identifying things in linear content that went out on the local radio. So we sort of essentially automated the clipping of the highlights of content from in local radio stations that they'd highlighted in their running orders, so that they could then surface those later for use on social media. It's a long, lengthy process that they have to do normally with editing suites and lots of different tools. We just tried to automate the entire thing, get it ready for them to just share without having to do any extra work. Mozro Manager is a talk I gave about. I gave a talk about this in more detail at last year's EuroPython. But this is a process for, a thing for processing TV and radio running orders to extract the structured metadata, so we can kind of reapply that to the content and do lots of interesting things with it. And also a project around BBC Images, a search tool for journalists to use to find images for their articles. We kind of enhanced enriched the metadata in the system so that they could more easily find images by advanced search tools. So first of all, we're going to talk about our sort of the way that we structure our project cycles. So this is kind of how we used to do things. So I'll contrast this to the next slide. But we kind of used to work in 8-week cycles with a project taking 6 weeks in 3 2-week sprints, and then having 2 weeks, what we used to call 2 weeks of tweaks. So just kind of tidying up and finishing things off and documenting things, that kind of thing. And then you'd sort of start the next cycle. We found that a small sort of change to how we worked made a big difference. So we introduced a week dedicated to research at the beginning of the cycle. So we do research week, go and meet our stakeholders and things, and sort of get to start to plan what we were going to do our 3 2-week sprints, and then have a dedicated week to just not write new features, just do some wrap up, and tidy up, and document things. Just to polish things off so that we weren't always kind of asking for extra time. And then we have an extra period of 2 weeks just called small projects. Gives you a chance to try out new things and do smaller bursts of work on new ideas that you might continue to a larger cycle. And that seems to work quite well. So our project cycles begin with ideation. So we can sometimes run ideation workshops, invite in stakeholders, people that we want to help and people we want to deliver for. But we kind of start with what the objectives of departments are, and what the organization is trying to achieve, and whether that's in audiences or otherwise. And we devise what we call how might we statements. So how might we do such and such towards our objectives, and start with that as a starting point. We then kind of do this process of what we call explode and converge. So you kind of come out with really wide, far-thinking ideas, Really, really broad thinking around this idea of how might we do such and such. And then we kind of narrow in on certain ideas and think, oh, okay, let's focus on this one and make this a really good idea. And kind of do that a few times, and it really helps sort of the ideas come through and not leaving anything sort of untouched. We kind of determine what, sort of pick an idea, determine what the objectives of that project would be, and then we start our research, we do our kind of bootstrapping, get all the tech set up and get everything ready to start working on, start doing what we call spikes, so just independent research on small ideas and just see, like, can we build this thing out of this, or can we use this technology to do this, and just try little things for just a couple of days and sort of try and lay some of the groundwork. Then we'll have, what our sprint goals are for the first 2 weeks, and then start ticketing things out on GitHub project boards usually. So yeah, in our research week, we do a lot of work with our stakeholders, so we kind of identify who those people might be, and see if we can get them to give us a bit of time each week to catch up, and we can share our work and get feedback from them quite quickly. So if it's a journalist that's going to be helped by this thing that we're building, we want them in the room and giving us direct feedback on telling us how they work and what how this would work for them. We want to learn about their existing systems, anything they're currently working with, and their workflows, how they actually operate, and get access to their systems and get some of the data that we might need, and get to know the people and processes as well. We also set up shadowing. So shadowing is where we kind of go in and sit down with a journalist on the job, a journalist or producer or editor or something like that, a program editor, and watch them do their job using the existing tools. If we're thinking of automating something or making something that will make their lives easier, watch them do their normal job as they watch how they work, see what their workflows are, and things like look for pain points, look for inefficiencies, look for slowness, any manual work that could be more automated. But importantly, just what is it they're trying to achieve, and what's stopping them from what's taking time and what's stopping them from getting things done. So we're a big user of AWS, so we have a lot of AWS services for building these kind of processing pipelines that we often build. So a lot of them use these technologies, so things like Lambda functions, which I'll explain on the next slide, step functions and state machines, databases, of course, and things like S3, file storage, SNS, SQS, that's notification and queue systems, and CloudWatch for logging as well. I'll go into each of those. So AWS Lambda is a way for you to run code without managing server infrastructure. So you actually just pay for any compute time. You don't have to provision for peak capacity or provision any servers for what you might need. It just, whenever things get run, all those things get done simultaneously. And you can write Lambdas you can write them in Python, you can write them in JavaScript or Go, or lots of other custom runtimes as well. And the top supported Python at the moment is 3.9, so we get to kind of work in Python 3.9, which is relatively modern. So step functions I mentioned, and state machines. So this is a kind of a workflow design tool. You design a workflow of something like a data processing pipeline. It could be a sequence of Lambda functions that all have a specific job, and you just chain them up and design your flow of how your workflow you want it to run. And Lambdas don't have to all be implemented in the same language, so you can have lots of pieces of your pipeline implemented in different languages if you so wish. You can design for failures and retries and parallelization and things like that. So what you can do is you can you sort of execute the state machine with some initial data. So like run this job with this bit of data. Each Lambda might sort of go off and do something and compute something or fetch something, and then it can pass that data along to the next Lambda. So you have this whole pipeline just building up a sequence of data or doing tasks or both. You can have parallel paths and decisional logic and retry logic, as I said, and you can kind of restart a whole state machine. The whole state machine either succeeds or fails, and so you can just restart one if you have a failure and you go and fix the reason for that failure. So it's easy to access the data from this view. You actually get a sort of graphical interface in the browser, and you can click through and view the exceptions and things like that. So here's an example of an exception at a particular step, and you can see the traceback and all that kind of thing of what went wrong and exactly where it was. We find that really useful. So a Lambda handler is your sort of entry point to your Lambda. So you'd have these in each of your Lambdas in your state machine. And you would essentially, as I described, you start with an event dictionary, which contains the initial data. And for each one, we'll bundle something more, or could bundle something more into that event and pass that on to the next one. And it's just as simple as having this event dictionary that you pass on, bundle stuff in, return it, and then it goes to the next Lambda. And the way that we have recently been validating and parsing the data that's flowing between Lambdas is using Pydantic, which you might have seen. So that's a data parsing and settings management library for Python using simple type annotations. So you can, in our use case, we're using it to parse and validate a Lambda's input data and also the configuration to the Lambda for different environments. So Pydantic works on these things called models. So you just define a model, describe what data that takes and what the types of that data is, and it will parse the data it's passed, do all the type conversions for you, and so you're essentially just passing JSON around between Lambdas, but you want it, it comes in as a dictionary, and you want it to be accessed with dot notation through this Pydantic model. So, for instance, you might have your Lambda handler function like this that takes an event. You pass that event, all the properties of all the keys and values of that event into this Pydantic model that you've described, and you might have it pull out a piece of that data, do a thing to it, and do whatever it needs to do. So for settings management, so you provide a load of environment variables for your settings for the Lambda, and this is an example where it needs a key and a certificate and a key. So you use that to authenticate against APIs. And here I've just defined this as needing the cert file path and the key file path, and provided a little property to just wrap that up in a single tuple. So when you do something like this, if you've got a web request to make, you can just provide that settings.cert, and you can make your authenticated API request. That's kind of the thing you can do with it. We've recently been using a lot of this. So this is in Amazon RDS, Aurora. You can use a Postgres-compatible database that is in the serverless engine. So you can, without having to provision servers to run your databases, you can just sort of ask for a database and provide a schema, and then it will just spin up capacity as it's needed, which is really useful for our kind of usage. So, for instance, this is the cloud formation. So this is the way you define your infrastructure. So here I've got perhaps on the end of the Lambda, the YAML for the Lambda. You would just say, I also like one of these databases, and these are the properties for it. So you define the capacity, that kind of thing. You get access to it, the SQL in the web console, but you can also access via the Boto3 library, or preferably using a database API like something like sqlalchemy. And you connect to it without you don't use credentials. You just use the AWS Secrets Manager as to provide your credentials. We have something called the apps portal, which is just a sort of EC2 server running. Hosting static files in S3, and it just provides a nice interface for us to quickly throw static files into static HTML into a bucket and serve sort of static websites, which is quite useful for our stuff. And for our use case, we provide access via either BBC login, so a two-factor authentication thing for staff, or if they've got a certificate file, they can access via that. And every project can just reuse this infrastructure, so it's a kind of a useful thing to just put APIs on and static sites and things. So it's great for single-page apps and things like that. We tend to use something called Chameleon, which is a templating language. So you just kind of devise a website content structure with a layout template, a basic template, and you create Chameleon templates for each page type. You would then create a sort of logic layer for retrieving the data that the web pages need and write out each page. So for instance, an episode page, if you were processing running orders and writing out episode pages, it'd be something like this. And sometimes just create a CLI for doing manual rewrites. We tend to use struct log. So this is a library for structured logging. So it gives you a really great interface to your log results when you're running code locally, which you'll see in the next slide. It's really easy to configure. You can also have use JSON logging, which is ideal for when you're running your code in AWS. So you can access and search the structured logs in CloudWatch. And this encourages good logging practice. So you just simply, so what we tend to do is let it use the basic logging in when we're running locally, and you get kind of colored output, and it's still structured. And then the bottom one is what it looks like in CloudWatch, so you can open up your JSON objects and see all the logging lines and all the details, the structured details in there. So we're using Pydantic to you can provide extra settings for specific things. So in this case, for the database, has an ARN for the resource that you're connecting to, the database you're connecting to, the secret manager, secret ARN, and the name of the database, and then just providing a prefix for the environment variables that it will read in and verify that you've got all the settings that you need. We use sqlalchemy for connecting to that serverless Postgres database. So we have, and you can see on the next slide, we've got a connection there using the Aurora Data API, which is the access point to your serverless Postgres instance. And there we've got a sort of declarative base of for the table schema, so we can easily run queries like this one. So get episode, go and select episodes from the episodes table where it's with this ID, and just return that. So nice and easy. And we also recently been using a Lambda function URL. So this is a way of actually deploying a whole API that's running on a Lambda rather than on a server itself. And you can design those with FastAPI. Makes it really easy. So you basically have a dedicated HTTP endpoint for your Lambda function. So you can throw traffic at it, and it will, you can determine how to manage that request and essentially run an API on there, which is a really, really nice way of doing things. So you can build a serverless REST API using FastAPI. So that's built on top of Starlet and Pydantic. So you can actually provide a serverless API for a serverless database. So you kind of have all these things without needing to spin up loads of instances of things. You just sort of declare what it is that you want, and it will spin it up accordingly. And you can easily add authentication to this if you need that for your APIs. So a really, really simple example of a fast API there on a Lambda function. So you just create a fast API instance, and there's a project called Mangum, which essentially does the magic of creating a Lambda handler that will feed on your request to the fast API, which just sort of makes it really easy. So just an example of the kind of thing that we built. So this week we just started a new project, and we kind of had this idea that we could inject highlights into the live stream of the news channel. So if something big happens on the news, we want to just put a marker on there so that people can easily find something that recently happened. So on iPlayer, you can view the last 2 hours of the news channel. So if something happened 15 minutes ago or an hour ago, we just want to be able to surface that as a highlight point and just mark that out so people can easily access it. And so the way that we built a very, very early MVP of that in just a couple of days, essentially, was so we essentially want a web page with the iPlayer on it and these kind of markers being the highlighted markers being surfaced. That essentially is going to fetch from a Lambda API, so just using one of those a Lambda with a URL just use that as an API, which is retrieving from this serverless Postgres database. So we can use that API to write into the database and read out of it, and essentially fetch that data through to the iPlayer on the demo page, which is just a static page we've thrown together on the apps portal. So what we've learned through this is, well, sort of what I was going to say was we tend to try and learn from all these project cycles and kind of move on. So we do move fast, but it's sort of move fast and learn things. We take our learnings into the next project. So if we pick up a new technology and we like it, we take that forward to the next project and share it with the rest of the team as well. We use spikes to try ideas out. So if we think we want to use something that might be a good idea, we can just spend a couple of days just trying that out, or and present that to the rest of the team, see what everybody thinks, and sort of prove a concept, see if it works, and move forward with it. So yeah, no project is perfect. So being quite sort of harsh about finishing things off and getting things absolutely perfect is not something we strive to do. There are no hard rules. So determine good practice and just keep improving. Because these are quite short-lived projects, so it's easy to be able to just move on and just learn from things. We do a lot of knowledge sharing. So as I said, when we've tried something new, share that with the rest of the team so that everybody can gain the experience, and show them good code examples of where that thing has been done before. Prioritize for delivery, so not getting bogged down in backlog and bug fixes and things, prioritizing on what's important for the stakeholders, and ideally finishing on time so that this thing can be taken forward or go to trial. And importantly, using the research week at the beginning and the wrap-up week at the end, using those wisely. So making the most of identifying who your stakeholders are, who you're going to be delivering for, finding your test users, getting to know them and how they work, and in wrap-up week, making sure you don't sort of leak into implementing new features and trying to take it further. You can leave that for another cycle if you want to revisit it, but just trying to wrap things up so it's not left sort of halfway through. That seems to be quite a good way of working. And that's all from me.